Now we are going to discuss the post correspondence problem, generally termed as PCP problem. It was introduced by Emil Post in 1946, and it has several applications in the theory of formal languages. So generally the problem is about an alphabet by the class of yes or no problems. So only two kinds of problems here: whether the PCP has the solution, it means yes. If the PCP don't have the solution, it means no. So generally they have given a two lists. List 1, namely with x, all the elements of x is called as x1, x2 and so on, xn. And another set, namely y, all the elements of y is called as namely y1, y2 and so on, yn. See, first of all, the primary condition here is the number of elements in x and the number of elements in y should be same. But the xi is a string which need not to be the corresponding yi string, need not to be same. But number of elements in x and number of elements in y are same. And for example, here we are going to discuss the alphabet over 0, 1 to determine whether it has a solution or not. This is the condition. So for example, here xi j comma xi k xi and so on xim. It means, for example, if I place x1, x2, x3, here I should place y1, y2, y3. Here the concatenation of x1, x2, x3 is equal to y1, y2, y3. It means we can conclude that the PCP has a solution. For example, you may repeat the any xi. For example, if I write x1, x3, x2, here y1, y3, y2, you may change the order or you may repeat the element. For example, x1, x3, x3, y1. So similarly, y1, y3, y3, y1. If the both LHS concatenation and RHS concatenation is equals, then we can conclude that PCP has the solution. But only one thing is, whatever xi is placed, corresponding I need to be placed. You may repeat or you may extend any number of times, and you may randomly place any xi, but corresponding yi need to be placed. At last, if LHS is equal to RHS, we conclude PCP has a solution. Now here we are going to discuss one problem. Here x equal to b, comma ba triple b, comma ba, and y equal to triple b, comma ba and a. Here it means x1 equal to b and x2 equal to ba triple b and x3 equal to ba. y1 equal to triple b, y2 equal to ba and y3 equal to a as shown in below. Now one solution here, I place x2, x1, x1, x3 and corresponding x2 here we LHS I place it in the sense corresponding y2, x1 means y1, x1 means y1, x3 means y3. Now what is x2? x2 here is ba b cube. Okay. Now ba b cube. What is x1? Is b. What is x1? Is b. What is x3? ba. Now come to the y2. y2 is ba. y1 means b cube. y1 means b cube. y3 means a. Now read the entire LHS. ba 6b is a. Now RHS ba 6b is a. Both LHS and RHS are same. So PCP here has a solution. Now observe the second example. Is the PCP has a solution for this or not? But here we can predict that this second example don't have the solution. Why? Because if you observe x1 0 1, y1 0 1 square, which has the length more than the x1, x2 is 1, y2 is 1 0, which has the y2 also similarly length more than the x2, x3 is 1 and here y3 is 1 square. Here the y3 is also more than the length of x3. Obviously here whatever the arrangement doesn't give a solution, because each yi is length more than the corresponding xi. So we can't place the LHS equal to RHS by placing Xi's and Y's in any order and in any length, any number of repetitions. So if you observe, this is one kind of problem gaming solution like dominus. Now a domino having a upper half and a lower half, so they are giving different types of dominoes. Now we need to predict the particular solution is there, the gaming has the solution or not. So for example, come to the dominus one example here. See, now find at least 3 solutions to PCP defined by these dominoes. Now this is x1 1, y1 triple 1, x2 1 0 and y2 is 0, and x3 is 1 0 triple 1 and y3 is 1 0. So observe, if I want to start the solution by x1, obviously I should take corresponding y1, but here no x2 or y2 has the consecutive first two ones, so we should not take this one. If I take x2, obviously we should take y2, but x2 start by 1 and y2 start by 0, we should not take. If I take x3, corresponding y3 will be taken, but if you take x3 1 0 triple 1 and y3 is only 1 0. So for example, we will practice in a new table, new document, this one as a small so for example, see here now. So there is a scope for taking x3 and y3. So if you take x3, what happen? 1 0 triple 1, and if you take corresponding y3, what happen? 1 0. And now in the LHS side triple 1 is there, so to get a more ones at RHS side, obviously next step should be x1. So here we should take compulsorily x1, so correspondingly we should take compulsorily y1. So once if you taken a y1, in the sense, what is y1, what is x1? First of all 1. What is y1? First of all triple 1. Now if you observe LHS and RHS, LHS side is 4 ones at rightmost side and RHS side is 3 ones at rightmost side. Now if you take x2, it never be a solution. If you take y2, it also never be a solution. So once again, obviously we should repeat x1. So here it means 1. So corresponding y1 we should take. So one more 1 will come. Y1 means triple 1. So now if you observe, LHS side is 5 ones and RHS side is 6 ones. Now if you take x2, here 6th one and 0 will come. Now corresponding y2 if you take, no ones are increase, already 6 ones we have, sufficient ones we have, only 0 is obtained. Now if you observe, LHS and RHS are same, means now this problem has a solution. See, remember, once a solution is found, we can give any number, infinite number of solutions, any number of solutions. Simply, no need to go for the new solution, simply repeat this pattern. For example, Control C and simply repeat this pattern, like it means, for example, now repeat this pattern, simply whatever it is produced, now repeat the pattern. Now it's also another solution. Like this, we can give n number of infinite solutions. And now observe, Another question. Prove that this problem has a solution or not. Obviously, if you observe, this is x1 and corresponding y1, x2 corresponding y2, x3 corresponding y3. Obviously, this problem also don't have a solution because each yi is greater of length is greater of corresponding xi, so it don't have a solution. And come to the 10.21, we need to find whether it has a solution or not. But if you observe, here x1 and corresponding y1, x2 corresponding y2, x3 corresponding y3. If you observe, x1 start by 0, whereas y1 start by 1, x2 start by 1, whereas y2 start by 0, x3 start by 0, whereas y2 start by 1. So there is no scope for LHS equal to RHS, so this one also don't have a solution. So like this we can identify whether the PCP has a solution or not.